thanks a lot for putting the paper on the program. This is joint work with Alessandra, Rosario, and Gino. And the question we're interested here is how robots are transforming the workplace. So ever since the Industrial Revolution, machines have been transforming the way we do work. In the 19th century, it was about steam-powered mechanized cotton spinning displacing workers. Today, it's about industrialized robots. And in 2015, there were already 1.6 million robots working around the globe, and that number was expected to double by 2020. And why is that interesting? Well, the future of robots is quite uncertain. With the growth of computing power, artificial intelligence, and machine learning, we're very likely to soon see robots outside of manufacturing taking over a significant fraction of jobs, even in the service sector. So according to estimates by Frey Osborne, around half of US employment is at risk of being automated within 20 years. So here you have a picture of early automation and the Ford production plant. And you see that was what typically back then, machines and workers were closely working together. And machines actually increased the marginal product of labor. By contrast, if you look at modern day car manufacturing, you don't see any workers. So basically, robots are perfect substitutes for production workers. And you either use workers or you use machines, but you definitely won't use them together. So the key question we're trying to address here is, how do robots affect jobs and efficiency of production at the firm level? And a main challenge is to have a reliable measure of robot use and robot adoption at the firm level. The International Federation of Robotics provides some statistics, but these are available only at the broad industry level. And it's hard to know whether a specific firm is actually employing a robot or not. And we use as a proxy for robot adoption data on firm level imports, and there's a specific product code that is actually an industrial robot. So we can see to some extent whether firms are using robots because they're importing them. And we're going to look on the effect on employment, and there's going to be a productivity effect. So robots are going to make the firm more productive, and that is increases sales and workers. On the other hand, robots will directly displace workers, and that is going to reduce employment. We're also going to look at heterogeneity of these employment effects by skill level, and we are going to look at other firm outcomes, in particular sales, labor productivity, and TFP. And our crucial contribution is that this is the first paper to provide causal firm level evidence on the impact of robots. So what we find is that robot adopters are bigger and more productive, and typically firms scale up when they start using robots. So employment, sales, and efficiency all increase. But as we also show that very often firms start using robots when they have positive demand shocks that are there even without the robot adoption. So once you condition on these demand shocks, then actually employment falls when firms start using robots or when they increase the intensity of the robot use, while efficiency always increases in robots. And who gains? Well, it's mainly the highly skilled workers, the engineers and the managers who benefit from the robot, while the other workers lose out. I'm going to skip in the interest of time over the related literature. And let's go to the conceptual framework, which is a simple partial equilibrium model that will motivate our identification. So firms basically face a downward sloping demand curve and they're monopolists. Firms are heterogeneous in productivity phi, and they aggregate a continuum of tasks Z in a Cobb-Douglas fashion, and each task can either be done by capital or by labor. And in principle, it's cheaper to do each task by using robot capital as long as the price RI of robot capital is lower than the wage. So this endogenously generates a production function that has this capital and labor with Cobb-Douglas aggregators, but what is endogenous is kappa, the share of tasks that can be done by capital, so by robots. That's a choice here. So firms are going to maximize profits and they choose optimally the inputs of capital labor, but they're also going to choose optimally what fraction of tasks they want to automate. So for each task you want to automate, you have a fixed cost in terms of skilled engineers who get a wage age. So when you combine the first order conditions for capital and labor, you can get at the elasticity of employment with respect to the intensity of robot use kappa. And there are two effects basically. On the one hand, robots reduce costs as long as wages are larger than the cost of robot capital RI. And how much sales increase depends on the elasticity of demand sigma. So there's a productivity effect, the firm expands, and that increases the demand for labor. On the other hand, there's a direct displacement effect whereby workers are displaced with machines, and that reduces labor demand. So ultimately, it's an empirical question which of these two effects is stronger. Finally, firms are also choosing optimally the fraction of task kappa that they want to produce with robots. And there is going to be a convex cost for, so it's any additional task is more costly to automate, and rho I is basically the firm-specific factor that governs how easy it is to replace tasks with robots, and that depends basically on the employment composition of the firm. So some tasks get more easily replaced by robots than others, like welding or painting. And then from the first order condition for kappa, you get the optimal robot intensity of each firm. And importantly, that optimal robot intensity is increasing in demand. So when firms face higher demand, they also use more robots. It's increasing productivity. So larger, more productive firms always use more robots. It's increasing in the cost advantage of using robots, and it's increasing in replaceability. So the easier it is to replace workers with robots, the higher the robot intensity. What's the key threat to identification? Well, there might be these unobserved demand shocks, A, that on the one hand increase robot intensity, and on the other hand, they increase employment. So when you just regress employment L on robots, then the effect you get is upward bias due to this unobserved positive demand shock. So in order to get at the causal effect of robots, we propose two alternative strategies. The first one is to take the first order conditions for capital and kappa, robot intensity, and by combining them, we get a measure of robot intensity that is just driven by the cost-saving effects of automation. And that depends basically on W over Ri. So basically, how large are cost savings of robots in the industry, and rho I, how easy it is in the industry or for the firm to replace workers with robots, which depends on the employment composition. So this robot intensity should be independent of these demand shocks. Alternatively, we construct an instrument that is based on a similar idea of reductions in cost for adopting robots and benefits of adopting robots, which is the interaction basically of this firm-specific replaceability, rho, and the suitability of the industry for robots. So some industry like car manufacturing are more suitable for automated production than others like textiles. What do we do in terms of the data? So in principle, we observe the universe of French firms for 20 years, 94 to 2013. And we have all economic activities except for government. Crucially, we also observe imports and exports at the 8-digit level by origin country. So we know whether the firm imports one specific product, which is a robot, and from where. We also have balance sheet data that allows us to construct the firm's capital stock or measures of efficiency like value added per worker or TFP. And we also know something about the employment composition In principle, we have 5 occupation categories, and we will specifically look at the high-skilled professions, scientists, managers, and engineers. And we will also focus in our empirics on manufacturing firms with at least 10 employees, because robots are most prevalent in manufacturing, and there are few firms in the service sector that use robots. So here's just how our firm-level trade data track the aggregate robot import data, and they track them quite closely. We don't have the government sector, so it's not all of the robot imports, but most of it. When you look at the number of robot importers in all sectors, by 2014, there were around 1,700 firms importing robots, and around half of them was in manufacturing. Outside of manufacturing, there are actually many wholesalers who import robots, but we will exclude these firms. In total, the cumulated imports were around 2 billion euros in terms of robots. In which industries are robots used? Well, one is wholesale trade that we will exclude, but for the rest, the industries that use a lot of robots are manufacturing industries like machinery and equipment, rubber products, fabricated metals, or cars. So these are industries that are very robot intensive. In terms of our sample in manufacturing, we have 746 firms that use robots during the sample period, out of around 65,000 firms. So it's less than 1% of firms, but robot adopters are much larger, around 10 times larger in terms of sales and employment than non-robot adopters. And they're also much more efficient in terms of TFP. They also employ a higher share of skilled workers. So overall, even though they make up only for a small fraction of firms, they make up for a significant fraction of sales and employment in France. So let's first look at the non-causal effect. What we do is to run a diff event study. And what we have is to run the log of an outcome, which is firm industry I, year T specific, on a firm fixed effect, an industry by year fixed effect, a dummy for robot adoption, which is one after the first year or from the first year on from which the firm uses a robot, and some controls, which are measured at the baseline and interacted with year dummies. And these characteristics are initial sales, import, and export status of the firm. And what you find with this exercise, that robots seem to be positive across the board. They increase sales, employment, productivity in terms of value added per worker or TFP, and they don't have much of an impact on the employment share of the skilled workers. But this is, as I say, not a causal effect. So in fact, there are significant pre-trends in the data. So there are these unobserved demand shocks that happen before the firm actually starts using robots. So let's consider a treatment effect that is allowed to vary by time. Let's define T0, the first year where the firm starts importing a robot, and T-5 is 5 years before, T5 is 5 years after. For the rest, we keep the same specification. And what you see then is that when you look at sales, that sales already start increasing 5 years before the first robot import, and so does employment. So actually there seem to be this positive pre-trend that induce firms to select into robot adoption. And after the first import of the robot at T0, sales stop actually increasing, and employment actually starts to go down. So there seems to be this pre-trend, and using just a naive diff and diff doesn't get us at the causal effect of robots because of this endogenous selection into the treatment. On the other hand, when you look at efficiency in terms of sales per worker, but I could show you a similar picture for TFP, efficiency only increases after the robot is imported. Okay, so the efficiency effects arise exposed, and the employment share of the highly skilled engineers and managers also only rises after the robot has been imported. So because of that, we think that the diff and diff estimates are not reliable. And instead, we use our model that suggests to us to use a different measure of robot intensity that should be causal, which is basically the total stock of robots relative to their total capital stock. So it's how intensive is the firm in the use of robots. Here we are going to look only at those firms that use robots, so 742 robot adopters, and look at changes in robot intensity that should be purged from these unobserved demand shocks. For the rest, we keep the same fixed effects and covariates. And then we find that actually an increase in robot intensity within the firm is associated with a drop in sales and a drop in employment that is quite significant, whereas efficiency, value added per worker, and TFP increase, and the employment share of the highly skilled also goes up significantly. And that corroborates our expectation from the diff and diff with time varying treatment effects, that the employment effects of the robots are actually not positive. As an alternative strategy, we do an IV. And for that, we will look at long differences. So we look at the average annual growth rate of outcomes, delta YFI, and we're going to regress it on the change in robot adoption. So we're going to look at a switch into the use of robots. So delta robot adoption is 1 for those firms that change their robot status and switch into using robots during the sample period. We're going to control for industry fixed effect and observables at the firm and industry level. And of course, we need to instrument for the change in robot adoption, because otherwise we're going to pick up these unobserved demand effects. In order to construct the instrument, we're going to do the following. We're going first to look at the firm level measure of reproducibility of tasks by robots that we construct following Gretz and Michaels. So they have, for each occupation in the US, coded it whether this occupation is replaceable by a robot according to the task performed by the occupation. So for example, if an occupation does welding, painting, and assembling, which can also be done by a robot, then that task will be replaceable by a robot. And fortunately, for the pre-sample year 1994, we have a more detailed employment composition of each firm with 29 occupations. So we will map these tasks from Gretz and Michaels, whether this replaceability from the US occupations to the French classification. And this gives us a replaceability of the occupation for 29 occupations, and then we will just wait with the employment share of the occupation in the year 1994. This gives us a measure of firm level replaceability of workers by robots. And second, we will interact this with an industry measure of how suitable the industry is for using robots. So the car industry is much more suitable than the textile industry for using robots. So our industry level measure of robot suitability will be the industry level robot stock divided by the industry level capital stock, taking out always the robot stock and the capital stock of the firm that we're looking at. And finally, this gives us an instrument, the interaction between the firm level and the industry level measure of robots gives us the robot exposure of the firm in industry I. And we will look at robot exposure at the beginning of the sample as a predictor for whether the firm starts using robots. Let's look at the OLS, which is not causal. If we do that, then like before, we get positive effects of robot adoption on sales, employment, efficiency, and no effect on the employment share of the highly skilled, in line with our yearly panel. But this changes crucially when we do the IV. So the first stage here is in column 1, which is the change in robot adoption, and we predict it with the robot exposure of the firm. We also take control for the replaceability of the tasks at the firm level and the robot intensity of the industry. And you see that the instrument is significant with a t-statistic of 2.9. So the instrument is sufficiently strong. And in columns 2 to 7, we have the second stage IB estimate. And here we don't find now any significant effect on sales. We find a significantly negative effect on employment, and we find positive effects on efficiency. So sales per worker, TFP, and value added per worker. And we also find a significant increase in the employment share of the highly skilled. The F statistic is not super high, so we would like to look also at the reduced form and see whether it's significant, so that we're safe in terms of weak instruments. And indeed, the reduced form has the same sign as the second stage always, and is also always significant, except for sales, which were also not significant in the second stage. We do some robustness by including additional industry interactions with replaceability, which is the key threat to identification, right? You can think of our instrument as being a diff in diff across occupations and robot intensity at the industry level. So what's the difference in the growth rate of the outcome of high versus low replaceability firms in high versus low robot intensity industries? This is basically the idea from the identification. So we include additional interaction terms, and our results are robust to that. So you can see the OLS effect, which is a 2.3 employment reduction in response to robot. That can be decomposed into an exogenous part, which is due to these supply shocks, and an endogenous part due to demand shocks. And we find that the exogenous part of adoption explains around a 2.4 percentage point employment reduction, while the unobserved demand shocks actually lead to a 4.7 percentage point employment increase. So you see the OLS basically gives us a positive because these unobserved demand shocks outweigh the negative exogenous robot shocks. So to conclude, we have the first causal effect of robot paper at the firm level. So robots increase efficiency causally, but they also reduce employment at the firm level, and it displays production workers at the expense of highly skilled workers. Because sales don't really increase, this is consistent with excessive automation. And I will stop here.
Thank you, Harald. I've got 3 questions from the audience, and then Jean Grossman would like to intervene. So Richard Forslid is asking, what about the use of domestically produced robots? Since you're not observing them, you're only using imported robots.
That is true. So actually, there's a paper by Ashemoglu and co-authors who have tried to look at some of the domestic robots as well. There are some, but there are not that many. Of course, to the extent that we are missing basically some of the treated firms and put them into the control group, if anything, that would basically downward bias the estimate of our treatment effect. Now, to the extent that our instrument undoes that, we should be okay.
Devin Chor is asking whether we should be thinking at robot adoption cost more as a per period recurring cost or as a sunk cost. So he's wondering whether there is a way to tease out this from the data, i.e. whether there is any lumpiness in within firm robot imports over time.
Yeah, indeed, firm imports of robots are quite lumpy, so the firms don't do that every year, usually. So it seems to be more of a fixed cost rather than a variable cost that really changes the whole way the firm is organized. So you don't want to do it all the time. We have a static model, and to do it reduced form, of course, one could think more seriously about it in terms of structurally estimating a dynamic model. So
Kirill Borysiak is asking actually 2 questions. So slight delay, but with your first strategy is asking whether it would be possible to show some evidence that the within firm change in robot intensity is mostly due to robot supply shock and not firm specific demand, for example, related to some technological changes. While for the strategy, specific replaceability not be an instrument by itself.
Okay, for the robot intensity, supply versus demand, I mean, according to our model, it should be a measure of the supply shocks. So basically reductions in the cost of robot capital. This is what it's picking up according to our model. But maybe we can talk about this more. And regarding the second question, which was, why don't we use the replaceability itself as an instrument at the firm level? We could be using that. We have been doing that at some point, but then we were not so convinced that the replaceability of the initial composition of the workforce is really randomly assigned. So we would rather control for that and use the interaction with the additional industry variable, and then use industry fixed effects and use the within industry across firm variation to identify.
Okay, maybe Harald and Kirill, if you want to follow up on that, we can invite Kirill in the speaker session, and then you can chat over the coffee break. Kirill,
Yeah,
if you agree, we can ask Mandy to do so. Marcus Zimmerman is asking, from which countries do the imported robots come from? Is that dominated by only one or a few countries?
Well, there are some big robot exporters, namely Germany, Japan, South Korea, and a few others, Switzerland. So yes, there are certain countries that dominate basically the supply of robots.
Okay, let me give the floor to Jean Grossman, who also had the question. Jean?
Thanks. So I just, well, first let me say that very convincing, nice, clean identification among the robots papers. I think it's the most compelling in the cross section. I just noticed the two bottom bullets on your discussion that you on the slide that we're all looking at now that you didn't say out loud, but those are exactly my questions, which is how much can we really learn about the question we're interested in from these cross-sectional, cross-firm studies? We really want to know how change in robot technology is affecting the macroeconomy and the wages and the labor market. All the firms that are facing similar factor prices, facing similar commodity prices, these will change as a result of robots. So the real question we're interested in is really a time series question, and one that, you know, has really thorny identification issues. So lots of researchers turn to the cross section where these identification problems can be better handled. But I think the cost is we don't answer the question that we're really interested in.
You're right. I mean, ideally, we're interested in the GE. One could argue that so far robots are not as prevalent as one would think, at least not in France. So the GE effects are to some extent limited so far. But of course, if we want to predict what is happening in the future, we would like to do that. And for that, we need a structural model. Actually, there's the study by Acemoglu, Restrepo, and Lelarge, which is just in the cross-section, but they have looked at what happens to the other firms in the industry when some firms adopt robots, and actually their employment and sales go down because, of course, they have to compete with these robot adopters that have lower costs. So the industry level, at least, effects seem to be even more negative because we look only at the direct effect on of robots on the adopters, but on the other firms, there are also negative effects.
Can I just follow up, but just with respect to that last point, that then going to be compositional effects where the most productive and largest firms in the industry are growing at the expense of the less productive firms, which is going to have a further effect on employment.
Yeah, I agree with that, yeah. And it depends, of course, also on the elasticity of demand of the industry. And we have some preliminary results according to that, that when the elasticity of demand is high, then the employment effects of robots are more likely to be positive, and they are more negative in a low demand elasticity industry, where this replacement effect dominates these efficiency effects.
Harald, I miss an important point by Claire Lelarge. I'm relying this to you. She says that there's a data question, that industries do not seem to match IFR data very well. And her experience with the French data is that quite a few of the robot purchasers are in fact robot integrators rather than end users. And half of them end up classified in manufacturing industries rather than services. So she's suggesting whether you check that import flows match investment flow at the firm level. Because if this is the case, then it's fine. Otherwise, that won't be the case for integrator, because purchases of robots will be classified as intermediate inputs. Otherwise, your treatment group would be polluted by these firms, which have few replaceable jobs and high apparent robot intensity. And therefore, they are also experiencing a large demand shock. So some of your results might be, let's say, impacted by these robot integrators rather than robot users. I think it's an important comment, and I leave it to you.
Well, thanks a lot for this comment, Claire. We didn't know about that, and it's something that we should think of. And
I think she has a paper in AEIP Papers and Proceedings 2020, right, Claire? So also, if you want to follow up,